Becca, can you help me?
Of course.
Can you tell me the difference between implicit differentiation and partial differentiation?
Oh, that's easy. I discussed about implicit differentiation first. Do you know what implicit function is?
When you have an equation and y is not a subject, I guess.
Exactly. When x does not lead directly to y, or we can say that function of x and y equals something else. Example in this equation of eclipse.
In this equation, we still can express y as a function of x.
Yes, but we have to understand that expressing y as a subject is not a must. Besides, it might take time to do it. Sometimes it cannot be done.
Example: 2x plus y to the 3 equal to sign differentiate 2x plus 3y. Get it?
Now, we see how to do implicit differentiation. Look at the equation 1. We differentiate respect to x as usual. But when come to function y, we use chain rule.
Can we say like this? Every time we differentiate y, we differentiate as we differentiate x, and we have to multiply by dy dx.
Yes, we actually apply chain rule to differentiate y. Basically, what we do when we differentiate y function, we differentiate y function respect to y and multiply by dy over dx.
Understand?
Next, collect all dy over dx on one side and finally solve dy over dx.
Get it? Can you give me another question?
You try this one.
Okay.
Wow, impressive! What a good teacher I am. Now, we can proceed with partial differentiation. For partial differentiation, we can differentiate the function of two variables, either respect to the first variable or the second one. Only one rule you have to follow. When you differentiate the first variable, the second one will be treated as constant or vice versa.
Slowly, please.
Oh, I almost forgot. Partial differentiation does not use the same notation as usual differentiation. Notation for partial differentiation is z respect to x, means partial differentiation respect to x. And the very common notation used for partial differentiation is pronounced as del. So, dz over dx is pronounced as del z over del x.
Oh, del.
If we are given a function z, we want to do partial differentiation respect to x. differentiate all as usual. But remember, y is treated as constant. It will be like this.
Why do we get 0 when we differentiate?
Remember, y now is constant. You imagine that you substitute y with 5. Then, y to the power of 3 equals 5 to the power of 3 equals 125.
I get it. Now, I have a partially differentiate every time respect to y. So, we will get this.
Wow, you did great! So, these are few important things that you have to bear in mind when you want to do implicit differentiation and partial differentiation.
Thank you very much. It helps me a lot.
No big deal.